Is my microphone on? Alright guys, hey, what's up? So basically I'm going to explain the trig limits just to, get it better for you guys. Why the people who just pretty much saying why we did what we did, because I know a lot of people were talking about the trig limits. So let me just do that for you guys. Alright. There's different ways to approach it. So basically what she was saying, she was getting us an understanding of why what she was basically doing a step by step, giving us a visual and a also mathematical perspective about it. So basically, if I can get my shit together, maybe I can. Where's my book? 1 second, guys. There it is. Okay. Oh, crap. They can't do that. Yep, we can't have that as a problem because the port rule. Yeah, just stop. Alright. Okay. Just that one. Lock screen. Let's find. Alright, so pretty much. Continuity. Right here. Alright, basically, with trig limits, we're always given, we're trying to find, let's say we were trying to find, a limit. Let's see, let's put this in. Limit as x approaches 0 and sine of 0, sine of x over x, right? So we were seeing our goal was to figure out why that wasn't indeterminate, right? Right? It's a thing that she said you have to remember this. So the answer is 1, and I'm going to tell you why it is 1. In fact, I'm going to tell you why the answer is 1. So the answer is 1 for 2 different reasons. Okay. So basically, you were taught basically this. Basically, I wrote this all down. Yep, alright. So basically, this is the explanation. Right, so you have this. And then you have this right here. Right? And then you have the little triangle. And then you have, another triangle, in fact. Yeah, let me make that more where it's touching there. There we go. And then you have a little more of a triangle right here. Actually, now let me just draw it out. You have basically you have that. And basically this right here is the arc length. And we know that the arc length is equal. So if this is 1, from here out to the tangential circle. Let me just make that. Actually, I need that to make that. So I should have did this afterwards. Right here. And then just move this. No. This is the arc length. So basically, this is 1. This is theta. And basically, the arc length is equal to r theta is equal to 1 times theta, which is equal to theta. And the reason why that is because the basics of the arc length. We know that s is equal to r times theta. Our radius was 1, and our theta right there as we try to seek an angle, right? Okay. All right, well, that thing is bothering me really much. There we go. That's much better. Okay. So basically, that's what we're trying to find. And if that was a circle, whole entire circle, that is what we were saying. Now, we're trying to use the triangle, I guess theorem. But they were trying. That's what she was trying to get across with the similar triangles. Basically, opposite over hypotenuse is equal to the sine of theta. And we know that the hypotenuse is 1. And the reason why the hypotenuse is 1, because it says it's 1 right there. So 1 over 1, which is equal to sine of theta. And the sine of theta, so we know that the opposite is equal to the sine of theta. Jesus Christ, Mom. Oh my God. Opposite is equal to sine of theta. So since the opposite is equal to sine of theta, that makes an interesting approach there. Yep, that makes an interesting approach, because now we have, since that is equal to the opposite, we also have that 1 over opposite is equal to cosecant theta also, right? So basically we have this thing, we have sine, and basically what we want to do, and our goal is to try to do, is just we're trying to get them, what we're using, or this is where we get into the explanation of the squeeze theorem. So we're trying to get into somewhere where we can find, like how she was doing something like this with the intervals. Is it 1, 2, 3, and then basically you have 1 over 1, and then it switches due to the value. So this becomes 1, this becomes 1/2, and this becomes 1/3. Okay. So basically, we have that. Let's make that orange so we can put a special. Okay. Let's not put that. Let's just put I'm acting OCD now. All right. So basically, we have that, and with that, right? We know that our sine theta. So we know that it's our sine theta is equal to, as we can see, the sine of theta. So opposite over the hypotenuse is equal to sine theta. And we said our sine theta is equal to our opposite And then we have our sine theta. Since the sine theta is equal to opposite, so opposite or hypotenuse, so that's the little triangle. And then we have our big triangle, which is opposite over adjacent, which is 1. So let me see. Let me just rewrite that. Let's see. Opposite over adjacent is equal to the tangent of theta. And then all between that, we have this angle right here, which is an angle. That angle. This right here is an angle. So the arc length is the angle, which is weird, right? The arc length is the angle. All right. So since that's opposite over adjacent, so then also the tangent of theta is also equal to the opposite, which is the opposite we said was 1 over what? Adjacent, I guess. Right? Is that right? No, it's opposite over adjacent, which is 1. So opposite. And we know opposite is equal. So since we have the same things for those, so opposite is equal to tangent of theta. Since we have that same thing, we can set an inequality saying that the sine of theta is greater than or equal to theta, which is greater than or equal to tangent of theta. And the reason why we did that was, first, we have our little triangle. Between, we have our angle, and then we have our big triangle. So basically, you're looking at this. So you're looking at the little triangle, call this little, is greater than or equal to the arc length, theta, which is greater than or equal to big triangle. Basically. Let's make this call this. Make it little. And we have big. And basically, we have our arc length, so in between. All right, so basically, we have that. And what she wanted to do was, she wanted to have us think about it up there. So how are we supposed to get 1, basically? That's what she wants us to do. How are we supposed to get 1? So what you can do, actually, is take the reciprocal of all the other numbers. Oh, I mean all the other, take the reciprocal of them, pretty much. And we get 1 over sine of theta. And then it switches. It's greater than or equal to 1 over theta. So basically, 1 over theta. And it is greater than or equal to the cosine of theta over sine of theta. Because basically that's what 1 over tangent is. And then after that, what you want to do to get to let's say sine of theta over theta, because our goal is, let's put our goal. Let's put it in. Nah, that's too ugly. Let's put in goal. Our goal is to get our sine of theta over theta in between. So we want it in between, right? So basically, in able to do that, we have to what? What do we have to do? Well, in able to do this, we have to multiply by sine of theta. So once we multiply a sine of theta, we get, let's say 1 is greater than or equal to sine of theta over theta. And then we get that is greater than or equal to cosine of theta. And then all you need to do now is take the limit of the whole thing. Of pretty much each one. Of 0, you can do 0 from the plus, whatever, just 0, period. I mean, yeah, it doesn't matter. 0, period. Take the limit as 0, period. Let's say 0, 0, 0. Right. Is that right? Yep, okay. Take the limit as 0, period, right? So once we have the limit of x goes to 0 of 1 is greater than or equal to the limit as x approaches 0 of sine of theta over theta. Basically, this is the squeeze theorem. It's taking a function and saying that since this blah 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 is this, and they both have to be, so this is what it's saying. It's saying if, let's get the squeeze theorem. Squeeze theorem. And I have it, and I don't know where it is. Great job for losing it. Chain rule. Yeah, that's another way you can do calculus. Another way I'm going to teach you is a calculus way. And it will take time for you to sink in your head, but like she said, we were going to learn derivatives. Derivatives are easy once you get them in your head. They're like a wonder for you. Like you already know everything, pretty much. That's how it is. Where is squeeze thing? Where did I learn squeeze? Okay, so basically, it's saying, just forget it. I can do it myself. Basically, it's saying h of x, let's say f of x, and g of x. Okay. So basically, that's what it's saying. It's saying if you do the limit, as to say x approaches a of h of x, and then is equal to the limit x approaches a of g of x, and it equals L. So then f of x, the limit is f of x approaches a of f of x equals L. So basically, we're trying to find f of x. We're trying to find this function. Trying to find this right here. This right here. Yep, that function right there. I like the laser tail. All right, let's get to business. So basically, if this is L f of x, and this is L, then that means f of x is equal to L. That's what it's saying. That's all it's saying. So basically, that's the same thing with what I was saying with the limits. Alright, so I can continue with that color. Actually, I like that other red. It's a really good red. yellow. Let's see, because that red is better. This is a brighter red, but I always love like the darker reds, the blood red. Anyway, I'm daydreaming. Sorry. I'm always daydreaming. Why? And now I'm talking to myself. Great. I feel like, well, technically I'm talking. Just do the problem. They're like, shut up. Alright. You can skip to, I guess. I'm here now. Alright, so this is greater than or equal to the limit as sine A over theta. And that's going to be 1, obviously. Yeah, this is a constant. The limit as x approaches 0, sine is 0, 0, so that stays. So the limit as x approaches 0 of the sine of theta over theta. And basically, that is what's going to give us our problem. And then we put cosine of theta. Let's just do this right here. So the cosine of 0 is equal to 1. So basically that becomes 1. And then that means that the limit as x approaches 0, since that is true, of sine of theta over theta is equal to 1. And that is our answer. So that's why it is equal, in fact, to 1. Here's another one. Another one is due to trig. Not trig, but what's it called? Let's say derivatives. Now derivatives, they are very annoying. Very annoying. Depending on what thing that you're using them for, but basically, if you oh, I'm trying to talk with my parents. Mom has a big mouth. That's all I said. All right. So basically, we get to this is something called Hopital's rule. Basically, when you get to the x of sine of theta over theta, and then we're like, oh, so you just plug in 0 over 0, and we get 0 over 0, 0. And then it's indeterminate. So basically what you can do, if you know derivatives, you can take the derivative of that function. So basically, of top and bottom, you want to do d over dx over d over dx. And just get that rid of that. So basically what you're doing is doing this. You're doing the sine of theta, the derivative of the sine of theta is equal to what? And then you're doing the derivative let's see, theta. Any constant is going to be 1, definitely. So basically, the derivative is going to be the cosine of theta. Because what this is saying is the cosine of theta. That's the rule of derivatives. It's going to be the cosine of theta. So basically, plug in that 0, cosine of 0 over 1, which is just 1. Yeah, I'm pretty sure theta equals 1, right? Yeah, anything constant or anything just like laying there is just gonna be 1. So basically, we're just left with the cosine of theta. Cosine of theta, and we get the cosine of 0, which is equal to, you guessed it, 1. So basically, that is why the limit as x approaches the limit as x approaches 0 of the sine of x over x is in fact equal to 1. Let me make it, you know, that's why is, let me make it, ooh, that's a nice color. I kind of like that too. Let's make it a gray. So that's why it is equal to, in fact, 1. And this is very, very important. Very important. When you're doing limits, you just have, this is something that you just have to memorize. And a lot of people do forget this, like she said. She was right. A lot of people do forget this. I know you guys don't even care. Well, I guess I hope that helps you out, guys. And if you guys need any more help or anything like that, well, you know, just ask. All right. Oh.